Hello everyone, and welcome back to another video. We're gonna do a new topic today, which is after linked list, which should just be Q. Okay. So what is a queue? A queue is a linear data structure that follows the FIFO principle, which is first in, first out, meaning the first element added is the first that should be removed, is the first one that should be removed. So think of it as like a line to like a store or to like a checkout or something like that. So you have like the cashier, and then this is you. If you're the first one going in after checking out, you'll be the first one to exit, and then people behind you will just basically follow in, So think of it as like a line at a store, or a task waiting for CPU time, basically. The basic idea is that elements are added at the back, or also called like tail or in queue. So for example, let's say the people in the back, right? As they're approaching, they're currently at the back adding to it, and then we call that in queue. And then U, or elements that are being removed at the front, are DQ, meaning that once you finish, you're DQ, That's the word. Yeah. You cannot randomly access like the middle, like an array. So for example, whoever's here, you can't randomly just remove the person who's already in line, and they're just waiting. And so you'll mostly interact only with the whoever's at the front or whoever's at the back. Very simple. Actually, I'm gonna just keep it for now. I don't know, why did I even erase it? It looks pretty cool. Okay, so queue operation at its core is there, like these are the standard operations that you should name clearly. You should be able to know clearly is the in queue X, or like you have X here, and then DQ, right? The X just shows that you add the element X to the back of the queue. So think of it like, for example, if you're using the people, it would be like a person's name that you're adding to the back. DQ doesn't matter because you just remove and then return the front element. So if the queue is empty, this is usually an error, or returns some special value / like throw exceptions, for DQ. For NQ, it's like if the queue is full, meaning if there is a fixed size array, then you can't add any more. So let's say the line can only fit like 5 people, right? You can't NQ after 5 because the lines can only hold up to 5. However, if there isn't a fixed size, then you can just keep adding. Now for DQ, it's, again, like I said, if the queue is already empty, then you can't do a DQ, because if a line has no one, who exactly are you like kicking them out? Like that doesn't make any sense. Other operations can be like, for example, I think it's called peek or / front. When you have this, it just returns the front element. Like, for example, again, if this is you and you called out the operation, the function, it's just gonna print out like your name or something. Or if it's an element, it'll print out what element it is, number 3 or whatever, like stuff like that. Another one is empty, which it's gonna return true if there is no element. And then, if there's an empty, there's also is full. And this one's technically optional because it kind of depends if there even is a fixed size like implementation for array queue. And then time complexity, we usually want it to be, for NQ and DQ would just be O of 1, both of them, because all you're doing is you're NQing an element and you're DQing an element. So where are the queues like used for? What are they useful for? Some good examples can be like task scheduling. This way, like you can sort of add tasks slash like jobs in order. Let's say like a printer, for example, like documents are waiting to be printed and they want to be printed in an order. Another one would be like the BFS, which that itself is a separate topic. So BFS, and it stands for breadth first search. They're good for like graphs slash like tree algorithms, and it uses like a queue to process node level by level. Or like handling requests, for example. Incoming network requests or customer support ticket, it usually comes in like first come, first serve, first come, and then once you're done, you just throw it out. Very simple. What else can I say before moving on to the coding part? Oh, yeah, that's right. How to basically implement a queue, right? There are two ways. We have like the array-based queue. And this one, it uses an array and two index, like front and back or front and rear, whatever. So, there's that. Or, of course, there's also the linked list based queue, which uses a node with data in it, and it has a next. It stores 2 pointers, which is one pointer at the front, which is the first node, and then the rear or last pointer for the last node. And so when you enqueue at the rear or the back. I'm not gonna write out. And then you dequeue from the front. Yeah. And now I'm gonna move to just writing the code out as quickly as possible. All right, and so this is the coding part. We're just gonna do a quick simple queue implementation. So, like for the class node, it's very similar. We have int data node next and all of that. Very simple, yeah. And I'm just gonna write it down here. Let's have static. We're gonna call it my queue, something like that. But yeah, let's comment just in case. So queue using first in, first out. And we're gonna do the linked list version because why not? Let's have a private node. We're gonna call it front. This points to the first element. And private node, we're gonna call it rear. This points to the last element. We're gonna have a purpose check. We're gonna have the first one, which is empty, like what I mentioned. Check if queue is empty. And from what I remember, it's a boolean and we called it is empty. Just gonna do that. So return front equals null. Now we write it like that. Basically says like if front is null, queue has no elements. That's what it's gonna say. Let's have the next one. I'm gonna write it out first before saying like the purpose. We're gonna call it public void enqueue. And like I said, enqueue, you're adding someone into the line, for example. So you want to add like with the data, So the purpose, add an element to the back of the queue. Now with this one, we have node, new node equals new node. And we're gonna have a data. Now, okay. Now we're gonna have a couple of cases, or just 2 cases. We have case 1, which is when queue is empty. And since we already wrote down the public the public boolean for that, we're just gonna do is empty. If is empty, then front equals rear, and that equals new node. This just shows that both front and rear points to new node. That's it. And then you just return. Yeah. Now, case 2. Very simple. Q has at least one element. Now, with this one, it means now we can add something, which means rear.next becomes new node, and then rear equals new node. Oops, I put rare. There we go. Now I'm gonna quickly comment it. So this old rear or back, however you call it, points to new node. And then for this one, we move the rear to new node. Simple as that. Let's write out the next one, which is the DQ. So public void DQ. Now with the DQ, you're just removing them. You know, you don't have to add the value. You're like the InQ, you know. So purpose, remove and return the front element. Now this one, let me check if I'm right. Okay, yeah. Again, we're gonna have the base case, which is it empty? Because if it is empty, there is nothing to DQ. Now with this one, we're gonna have to throw a runtime exception, where we will comment saying that the queue is empty, cannot DQ. The line is empty, no one to remove. We're gonna have the int value, we're gonna have the front, so now that we're done with the base case, we're gonna have the int value, and we're gonna have front.data. This one basically stores the value to return. Gonna have front equals front.next. This one is gonna move front to the next node. And then we're gonna have the comment there for now. Let's say if front is equal to null, then rear equals null. I'm gonna comment this one. So if front becomes null, that means the queue is now empty. So the rear should also be empty / null. I don't know why I chose rear. I should have just said back. That would have been a better word. Then we just return the value after the if. Oh, that's right. It's not public void. It's public int, because we're doing integers for elements. And then, okay, that should be, and that's it for the DQ. Very simple, very quick. Now, I think I did remember, we also mentioned the peak or front, but I'm gonna do peak. I'm gonna just call it peak. Again, this is a integer because we're looking at the value. Once again, the base case. If it's empty, we're gonna throw again a runtime exception. We're gonna again calling it the same thing. Q is empty, cannot peak. Now with this one, instead of dequeuing something, if there's no one to look at, what even is the point of looking at it, you know? And then you just so if it's not true, then we just return the front data. Yeah, very simple, very quick. And there was also oh wait, I forgot to write the purpose. That's right. Purpose, get the front element without removing it. And we're gonna do one more, which was the optional one that I mentioned. We're gonna print the queue from front to rear. So public void print queue Once again, if the line is empty, there is nothing to say. We just print out the line and say that the queue is empty. And then you return. If not, we grab a temporary temp, and we're going to have that equal to front. I'm going to print out, system print, not line by line, but we're going to do this, front. We're going to do that. Then we're going to write out the while statement. If temp is not equal to null, then we print out the temp.data. We're going to write an arrow for it because it looks nice. We want it to look nice. We'll put temp equals temp.next. Then after all of that, we print out null. Or rear. Or back. Or whatever. And that is it. So I just realized I'm going to remove all of this because we finished the linked list topic. So there is no point of writing all of that. I'm going to remove all of that. And I'm going to remove all of this. And then now we're going to write out the my queue. Give it an, I'm just going to call it queue. New my queue. Queue.enqueue. Let's add in some data. 10, 20, 30. Let's first do the print. I want to print it out. And based on what I wrote, I think what it's going to print out is first the front, then 10, then 20, and 10 is the front. So then 30, and then null, which is the rear. Like that. Afterward, let's do a quick test out the peak. Peak should just be q.peak, and it's going to print out like whatever's at the front. So it should be 10, not 100, but 10. Ooh, comment. Oh, Jesus. Let's print out the next one. We're going to try to dequeue. So dequeue. We're going to put dequeue. Let's remove. Actually, we're just. Oh, yeah, I forgot. We're just dequeuing. We're dequeuing. So we're not dequeuing at a certain value because we can't do that. We're just dequeuing whatever's at the front. So this is also 10. Now, if we do print it out, it should show front being 20, 30, and then null, which is the rear. Like that. Now we're going to dequeue the rest. So I'm not going to write out, just kind of think of it. We're going to dequeue that and then dequeue again. So this one will dequeue 20 and this one will dequeue 30. And when that happens, we're going to write out one more. And just to check, is the line empty or not? Is it empty? Question mark. And we put q dot is empty. Now with this one, it should print out true. So we run it. Oh. There we go. Front. That's the first. We implemented. We enqueued number 10, 20, and 30. So when we print it out, exactly how it was commented. Now we're gonna peak whoever's at the front, which is 10. After we dequeue 10. And then now it should be 20, 30. And then we continue to dequeue, which is 20 and 30. So now is it empty? Print out true. And that is it. So that's how you do it. And then I'll just go ahead and probably do some like LeetCode problems on the queue. Or maybe I just do stacks and then, But yeah, thanks for watching.